So my talk is about radare2 1.0, and this is a crucial milestone. Radare2 1.0 is something that people has been expecting for so many years. They were always thinking that next release will be 1.0. This talk is about explaining the whole development process that making this kind of software implies. So, if you don't know it, I'm the author of this thing called Radar. Well, in this talk, I will explain a little bit about the problems of the project, which kind of development issues that we have, which are the weak points, how to fix them, and well, the future plans for the project. This talk is more about developer reverse engineers, which is about people who likes development, but he's also doing reverse engineering or both on the other side. So it's just a concept I invented, and well, I hope if you are one of those who like to code and do reverse engineering, you will probably enjoy this talk. The culture of versioning is important. Every project has a different versioning number and a very different way for managing the releases. So there is no single way for doing this. Some people is just using 1.0 as a meaning for saying that this is the first release, first public version of something. Other people is just using 0.1. Other people think that 1.0 means that this is the first stable version, and other people think that 1.0 means that the software is complete, and so there is no reason for making anything else, at least for adding new functionalities or something like that. There is also a very different way of versioning the software. Some people is using, like, for example, Mozilla Firefox or Google Chrome are using just big numbers like 43, 44, and pressing just a big number. And they have like little version numbers, but the real release is just an integer number. Other projects are only having 2 digits, like nmap, core utils, PQ, etc. There are also other projects that are using 3 numbers for the version, like Radar, Capstone, Git, GNOME, Apache, etc. And these 3 numbers have different meanings. Some projects use it for specifying that the big number is a big release, so it's like a big milestone for the project. The second number means that it's like an evolution of the project, and the last number is bug fixes. So if you want to keep some kind of binary compatibility between versions, so you are just upgrading your software and you want to keep, or you want to be able to not have to recompile the projects that are linking against these libraries, you will keep the binary compatibility because the API will be the same and binary restriction will be compatible. And this information is encoded in. There are also other projects that are using 4 numbers like Tor, SQLite, Snort, and so on. There are also some weird projects like OpenSSL, which are using some meaningless letters and numbers, and it's a bit difficult to compare them and so on, because it's I mean, if you want to check if the new release is new than the previous one, you have to compare in many different ways, not just comparing a big number or comparing all the little numbers, or then using letters. And then there is some projects that are using beta, alpha names that are used a companion of the version number. And this information means that this is going to be a new release soon. So they're using like some pre-releases for letting people use and test the software through this. In Radar, I've been testing some of this. I mean, for example, I've been trying to use release candidates. I've been trying to announce some beta versions, alpha, etc. And at the end, nobody cares about that. I mean, users will only use the final release. They will never try a release candidate or never try a beta version. And if they do, they will probably not report anything. So the only way to get reported or to be notified about the users are using something, or they are finding some problems in a specific version is just make a new release. So here is where some projects start releasing using version numbers which are encoding the date of the release. Some other projects are just grabbing the snapshot from the Git, or just making a table from a specific date, or using just tips from Git. So the people are trying to push more frequently the releases. And I think that this is good. So, for example, some Linux releases are using a version that is happening, like, I mean, you don't have a specific version to use, so you're always having new releases or new versions of the distro, and there is no fixed or stable version of it. And some other projects are making like fixed date releases. For example, every month there is a new release, and this means that the code in Git must be stable, so people should be able to use it. And there is other people that are using some some release rules. That means that, for example, rules, they're using 6 weeks release cycle. And well, some versions ago, I decided to follow this cycle. So every 6 weeks, there is a new release. The good thing about 6 weeks releasing is that there is no predictive way to know when will be the next release. It's some kind of surprise. I mean, you are not expecting that the day one of every month there will be a new release. So it's like shifting some weeks back and forth, and at the end there is like you have some buffer for waiting 1-2 days for fixing or finishing some stuff. Daily compatibility is important, but not for all the projects. I mean, for example, radar, many people complain about I'm upgrading the radar, and so I have to recompile everything, I have to clean everything, remove the other versions, and so on. So there is no easy way to be able to define a specific AV compatibility with radar, mainly because it's a project that is evolving really fast. The reason of this is because there is so many contributors, there are so many ideas that we want to try, and it's funnier and better to just tell people that they have to use always the last version. And this way, we don't have to care about heavy compatibility, we don't have to care about stable versions, or defining some fixed APIs that can be deprecated for 2 years, for example, which will be really annoying, at least for me, because it will take so much time for maintaining, reviewing, and doing some kind of test that you are not gonna care at all, because some other projects or products are using this kind of development, and this is installing and keeping some really badly designed APIs for a long time. So I don't really care about heavy compatibility, but I really care about some stable versions, something that distros can use for packaging and distributing to the people. So this way, it's also possible to define some CVEs if there is any vulnerability, and we can just specify which is the patch is fixing this vulnerability, and distros can just support it. But as long as there is a new release every 6 weeks, it's also easy for the distributions to just grab a new version. So we will not have the problem that is happening in Debian right now, that the current distribution is shipping a 5-year-old version. So having more releases makes also gives more visibility to the project. So there will be more people getting notified about there is new release, there is new stuff, and it's also easier for us, the developers, to make a new release, because the changelog is shorter. You only have to review like 500 commits, not like 1 year of commits. We will be like 2,000 of them. This already happened. I mean, I know what's cleaning up like 2,000 commit messages just for making a release note. And this is really boring. I mean, you can spend like 1 week removing text from a changelog file, and this is not productive and not fun at all. So it's not. And I don't think that it's giving any kind of good thing to the project. So this is why I'm using releases for every 6 weeks. And there is also some understanding that the versioning numbers are in fact timelines. So when you know that this is a specific version, you see some numbers, you can identify that this version number is like 2 years ago or some months ago, or something like that. But if you are not following some kind of a specific release scheduling, you will end up not being able to identify this just with your mind. You will have to check commit logs and stuff like that. And I think that this is important. So, for example, some projects are changing the version numbers, like GTK, and they are trying to push more frequent releases and scheduling some milestones for long-term releases. Other projects are using different branches for development. in radare2 as well as in radar. I've been also trying to maintain a single branch. The reason of this is because if you are maintaining different branches, you will have to be porting patches from one branch to the other one. You will have to have more than one machine for testing all the comments that are happening there and running all the test suite and stuff like that. And then we will also have to maintain different branches in the test suite because every release can be breaking some tests. So we can specify that, okay, this version is stable with this version of the test suite. But at the end, writing tests and maintaining branches, porting patches and so on is a really boring work. And I don't think it's really giving us any kind of benefit. It's easier to just say to people, okay, just download the repository, run this script, and you will get everything running the last version. So the reason for this is because the project evolves really fast. We are trying to always refactor the code. There is any rule in the project that is saying people, okay, we have to keep this for a lot of time because otherwise it will be wrong idea. There is people using it. If there is something wrong or wrongly designed, and we can change it, we will change it. So I try not to maintain some API compatibility or stability, but we are trying to write unit tests and specify some kind of slowly progressive stabilizing the APIs for each of the modules internally of the project. So we can drop deprecated APIs faster and also change the behavior of the comments in a faster way. And this is also giving us more stability, more people being able to test everything, more complaints, and this is good. I mean, having people complaining means that there's people using it. And this is also good because as long as you have feedback, for me, in this project, I'm using or understanding complaints or usability problems as important bugs. Having a crash is important, but having people not being able to use the software because it's not working as they expected is also a problem because it must be natural. I mean, you should be typing stuff that you think that the software should be reacting in a specific way. You shouldn't be checking the help all the time. So if somebody thinks that this specific functionality must be done in any other way, so just feel an issue or just say something in the IRC or Telegram channel, and we can discuss it. I mean, I'm open for changing anything. We're also using GitHub intensively, so we are trying to encourage people to create new pull requests. And we are integrating the project with Jenkins, Redis, and Ampere, which are online services which are hooked to the GitHub. And every commit that we do, these services are building the whole project, running the whole test suite, and giving us some feedback. We have a bot in the IRC and saying that, okay, this specific commit is breaking this test, and we can then easily regress and identify what has changed and fix the test quickly. This is also nice because this is working for every pull request. So if you are contributing to the project and you are sending a patch, your patch will be compiled by these three services, and you will get some feedback saying that your patch is correct or it's not correct or it's breaking something. This doesn't mean that the pull request is correct. There is also a need for some code review. So are we 1.0 yet? Many people thought that after the 0.9 there will be 1.0, but then 0.9.1 arrived. Other people thought that after 0.9.9 there will be like finally the 1.0, but then I released the 0.10. Okay, so last release was 0.10.5. So what do you think will be the next version?
0.20.
Yep, so the project is reaching 1.0 finally. The idea for this is starting to change the way that we are releasing. And 1.0 means that the project has grown out to have a big community, not power for being able to live for its own. I mean, if I die tomorrow, the project will not stop being developed because there is people contributing every day, having like 5 to 10 pull requests every day, and doing code like everywhere. And I think that switching from the role of developer to the role of maintainer is hard, at least for me, because I prefer to develop and write stuff. But it's really important to teach or maintain the community and teach new people how they have to write their contributions, how to report properly, and so on. So 1.0 means that the project has reached 10 years old. The idea is that the next version will be 1.0, and this is after it will be in 3 weeks, something like that. I will keep releasing a new version every 6 weeks, just increasing all at one. And every year we increase 1.0. So it will be like over 9, there will be an increase of 1.0. This way we have a timeline. We can identify how a specific version is. We are also identifying that we can have fixed releases, so we can identify when the contributions are growing, when the contributions are getting lower, which functionalities are being introduced in new release. And this is better for all the maintenance. So it's I think that's a good decision for the whole maintenance of the project. Let's talk a little bit about the development of the project. In radare2, we are trying to not follow any strict development model. I have been trying different models and techniques for maintaining and developing the project. Actually, radare2 is based on ACR, which is a shell script that I wrote that generates shell script and runs shell script. And it's a r2con replacement. It's a tool that generates a configurable script. And this way you can, the final shell script is about 60 kilobytes, which is really small, and it runs in all systems, even on Windows. And after many years trying to teach people to use configure make, there is many people here that doesn't come from the Unix land, and they are coming from Windows or other systems that are not building over in this way. They were having many problems, like installing the same stuff in different paths, having problems with the library directories, or having multiple versions installed, and the main executable was the last version, but the library was old, and stuff like that. So finally decided to write this install shell script. This shell script is downloading the code from Git. It's building everything from scratch every time. So every time that you run this, it will be loading updating the repository and building a new version and installing it. And it's installing it using symlinks. The reason for this is because if you are developing, you don't want to rebuild everything and you don't want to install every time. So this way, you just have to go to the specific directory that you are doing some changes, just type make, and the whole new version will be ready for use. You don't have to change any environment variable, you don't have to install again, everything will be working. This works fine for single user environments. If you are doing this in a server with more than one user, it will not going to work unless you do this from root. But the idea is that this way is easier for everybody to use it. There are other scripts for installing in the home, like sys/user. So you can also install it in your home if you don't have system privileges in the box that you are installing it. All the make files are written by hand, and there are some precompiled SDB databases. SDB is a database that I wrote. It's a key value database that stores everything in memory and can sync in. The idea of this is that we can save anything in there. Everything is based on strings. You can represent everything as like a seal, for example. And when you are precompiling this, you are generating this hash table, which can be mapped by radare2, so it's not taking memory, and can use the hash table from this, can also use the hash table from memory. This way you can have like a huge database and not eat like 4 gigabytes. Also, it's possible to link several SDB databases one after the other. You can create a tree of different keys. And this allows us to have multiple SDBs, some of them exported to the project file, some of them that are not, etc. So, which are the weak points? The weak points are usually the complaints. The complaints are what the users are complaining when they are using the software. And those are the main complaints from the community. First is that comments are complex and are hard to remember. I can say that, okay, this can be partly true, but after maybe 1 week using it, you will get used to the comments, and if you understand the logic behind the structure of the comments, you will soon see that this statement is not true. Maybe at the beginning, or somebody that is not really using it can think that these comments are complex, but I think that at least have some kind of logic behind, not like WinDBG comments that are really weird and not really following any kind of consistency. And again, if you have any kind of problem or you think that some specific comment is not correct, just complain about it and just change it or discuss about a better way for doing that. Nobody knows all the futures of radare2. Yeah, that's correct. I mean, I'm aware of this. Many people are saying, oh, I have an idea and I'm going to implement it, and oh, I'm sorry, this is already done. But this can be fixed with documentation. We're trying to document more, to write blog posts, to make videos, congresses like that, so everybody can get notified and understand what's going on inside Radar. And you see the source code, you will easily understand how it's structured and so on. So there is no perfect way for fixing all these issues, but it's an evolution that we are trying to get better over time. There is no GUI. This is not true at all. I will explain why later. There are different user interfaces. The command line interface is maybe the best one that anybody can use, because it's easier for developing, it's easier for the users to extend or to modify or to play with them. And writing user interfaces is boring, and it's usually hard to keep the same speed that the core is following. So the user interface will be always behind the command line. Bindings are not idiomatic and they are hard to install and use. Well, I tried to fix this with r2py, and I think that's the best way to use radare2 from any scripting language. But there is still some people trying to use the APIs from the bindings, and I think that after the visuals, I will try to focus more in the native bindings. Native bindings are generated with Balabind, which is a tool that parses some interface files and generates a sweet interface file, or directly the final code for the project that Billy opened the library, still symbing the symbols, having all the definition of the signatures of functions, and wrapping them to give us bindings for the specific language. They are hard to use. Okay, yeah, they are hard to use because they are not idiomatic. I mean, you are writing in Python, you are expecting an IPython-like API, not a C-like API, same for Java or any other language. But this can be slowly fixed, trying to follow some kind of substitution rules that are changing the function names, and this will be implemented in Balabind. So actually, there are some filterings. For example, if you have a method that's called set, this is not going to work in all the languages because set is a keyword. There are other languages that are using a different keyword. So we are trying to develop radare2 a C API in a way that it's not conflicting in any other language. So the function's name should try to follow the model name, and then a meaningful method name that can be static or public. But at least when you know that the specific function, you know where you can find the source code and what's the purpose of it, and it's not conflicting in any other kind of language. Because of the other people complain about there is no documentation. Well, radare2 is self-documented. You type the question mark at the end of the prompt, you will get the help or some help. It's everything documented in C. If you read the GitHub code, and you will see that everything is there documented in something that can be compiled and runs. So if a compiler can understand this, you can also do that. There is some people writing documentation and doing some presentations about this. So this is slowly getting better. It's slow when working with big files. Yeah, that's true. I mean, there are some situations that can be faster, and I will try to get better on this kind of fields because it's not an easy problem. We're trying to, being consistent or being correct in all the possible situations is not a synonym of being fast. You are trying to do the things in a proper way. You are probably doing something rated twice or more than twice. And there are many places that I will explain a little bit that can be done in a faster. And well, it's vulnerable because it's written in C. This is true. C is not a secure language. It's just a low-level language, a system language that can build in any place. There are compilers for C, for anything. You can build radar in several systems as long as they are having a POSIX base. So if you have a POSIX library for the specific system, you can just cross-compile or compile radar for this platform. The main reason for choosing C is because 10 years ago was the only option that I could take for having or developing this kind of project. I have never think that using C++ was a good idea because it was making things even more complex. You are shipping a runtime library with the project, so it's doing everything bigger. The runtime library is not stable in your system, so you have to think against different libraries. The C++ language have evolved really a lot. So if you are trying to develop in C++ 17, it's much easier, much better, and much clearer the code to read. But there are also problems. Facing with other libraries, other languages, one is not as easy as in C. In C, when you're developing, is what you write is what you get, final language. So. And yes, it's vulnerable, but at least you have control of what you're doing. So let's see how to fix each of these. One of the issues is that there is a huge code base. The source code of radare2 is really big. This is not because the project is huge by itself, but because it's shipping some dependencies and some code from other projects that are inside the same repository. So there is, for example, code from Vinutils, code from Capstone, code from other projects like Roof, and so on. And if you try r2con, then you will see that there is like many libraries, and most of the code comes from this project. The idea is that having everything as modular as possible gives the opportunity of separating some parts of the project. Like, for example, all the plugins can be moved to separate repositories or package them via 2PM. So you can just remove the stuff that is not really used by most of the people in the by default installation. And if somebody wants to use some strange or not really common architecture, they can just install the plugin. So some of the ways for fixing these huge code-based problems are refactoring, trying to remove that code, testing everything, removing wrong code or wrongly assigned code, and trying to optimize slowly the whole problem. Disabling the plugins by default, you can use configure plugins shell script, which allows you to specify which plugin you want to build inside radar. So because by default, radar will build the plugins inside the model libraries. This means that the plugins will not be plugins at all because they are shipping inside the library. The reason for this is because loading in this way is way faster than loading different libraries and then passing all the headers and attaching to the system, etc. So this way you can just have all the plugins in a shot, so by default you will run faster. If you want faster startup, you can just disable most of the plugins. You can specify r2 no plugins environment variable, and this will disable the dynamic plugin functionality. Some of the deprecated or not used models or plugins have been moved to r2 extra repository, and they are available via r2pm. We are trying to delegate the responsibility of running the test suite to other machines. I'm not going to run the test suite. That can take like 10 minutes in my laptop to run after each commit or after each change I do. Because if I have to wait 10 minutes in every change, I'm slowing down a lot my performance coding. So having to wait for knowing if this is correct is not the best way for developing. So I think that it's better to just test different stuff, do whatever you think that is correct, push it, and then think another thing in another problem and wait for the results while you are doing another thing. This way you can parallelize the development and you are not getting blocked by a specific problem. Doing more review is very important, and having more people into the review team is also important, because for me it's taking too much time to review all the contributions, all the new code, all the code that was already there. And there is some effort in trying to always evolve the project, and be refactoring. So, for example, recently we have been modifying some of the parts of the project. Modifying means that we are using bool for Boolean values like true or false, instead of using integers. This is supported by C99, and this is not really a huge improvement, but it gives you some feedback in a way that when you know that something is returning a Boolean, you know that the only possible values will be 0 or 1. There will be not possible to have -1 or 2 or stuff like that. So this makes the function signature much clearer. It allows us to specify that we have to return an error or return a specific return code. We can use another parameter and pass this by reference. And this also making clear that you can use this, for example, in a loop, and just use it as conditional and stuff like that for breaking when something goes wrong. And standardizing the syntax is really important too. We have been doing this year an effort for defining some kind of a standard syntax for the project. The syntax can be strange for some people because, for example, I'm adding a space before every parenthesis and things like that. And some people think that this is weird, but well, I get used with this syntax when I was working with this JustStreamer project. All the known projects are written following this syntax. So I just changed some of the things that I think that are making the syntax more clear for the reader. This is important also because when you are reviewing code or you are looking for some specific part of the project, it's easier to grab for it. So you don't have to use some tools for it. So let's talk about the dependencies. The reason for shipping these libraries inside Radar is because I don't want to make Radar having the dependency problem that other projects have. C doesn't have a dependency manager. Node.js or Swift or Rust, for example. So this is a problem, because if you are trying to maintain or to integrate your project with other people, you end up having many problems, because, for example, some distributions will be shipping a specific version, which can be old. This can be a problem with this, because some specific versions can be buggy or can be wrong. And some people can be reporting bugs to your project when in reality they are bugs in another library. So, for example, I took code from Vinutius, which is GPL. This is conflicting with LGPL, which is the license that I'm using in radar2. The thing is that you can disable the plugins for this. So I'm using Vinutius mainly for assembling and disassembling. So I'm taking the code of the disassemblers. I was using this before Capstone existed. When Capstone was released, I was trying to use it as much as possible, because it's a nice API for using it. There is support for many common architectures, and there is also some internal representation that you can easily parse and use for analysis. There is also libmagic, which is a library for parsing headers and identifying the magic numbers of every file format. But there is some problems. The code from GNU is vulnerable, is huge. I mean, I think that last time I checked, it was like 18,000 lines of code. And I'm not going to ship a big dependency like this inside Radar. So I was checking different libraries, and I found that the OpenBSD one is pretty nice. I mean, the source code is not the best one. I found 2 vulnerabilities, I reported them, and they're fixed in upstream already. I'm trying all the ways to push all the bugs that I'm finding into the projects. I'm also using TCC, which is a stripped down version. TCC is a tiny C compiler. I'm using it basically for parsing include headers. So when you are interested in integrating or parsing a structure, you can just import this include file, and you will get the internal representation of the code for grabbing anonymous structure stringing networks, etc. I'm also using the bootloader for Linux and other systems. I'm using this for parsing all the file system and partition systems. So this way, I have a wrapper library, which wrapper source code, which is having all the structures that are inside group, so I can easily integrate new file systems that are supported by group inside Radar. And the things that I found is that the file system parsers in group are really buggy. They are not really checking almost anything. So you can easily find vulnerabilities in there and execute code, etc. So I fixed many bugs in there, and they are fixed in there, and I'm trying to push them to upstream, but it's hard because there are so many forks of graph, and there's SDB is all by me, and it's small, and I can keep it synced really easily. One of the problems of doing these kind of syncings is that if the project is not following the same syntax indentation and so on, it will look ugly. But if you are changing the syntax, you will not be able to check the differences with the new version. So it's good to do the minimum changes in these libraries. And if you do, just specify some patches files that can be applied at compile time. And well, there is also an SSL dependency, but it's not used at all right now. It was used by BigNam's computations and SSL for SCDPS and stuff like that. But it's not really used at all, so it's something that is work in progress. So let's talk about vulnerabilities and patches. Some external dependencies have vulnerabilities, or they can be buggy. So we try to, as long as we have a continuous integration system and we are testing everything, we have been reporting bugs and patches for all these projects. And as long as we have a segfault, we are trying to find the root of the problem, we are trying to fix it and report it. So we usually ship the fixes for these dependencies faster than before the original projects. And we are trying to push them, and well, this is a list of vulnerabilities that LifeSkills found in Capstone. He found way more than this one, but they have a CD assigned to them. The thing is that these vulnerabilities affect only versions from. The reason for this is because the last version of Capstone is 1 year ago, and it's not it's not shipped with Radar. Radar can build and can compile against this library, but the Capstone release is following the two branches development model. So they have a stable version and they have a development version. The development version is way better than the other one. They have many bug fixes, they have many new instructions supported in there, there are many new stuff in the internal representation of the instructions, etc. So there is no reason for using an old version, at least in r2, because we are interested in having always the last version of everything. And if you find any bug, just fix it and report it as soon as possible. So these issues affected radar2, but they got fixed in radar2 and reported to the project, and well, there is still some to get fixed in upstream. Well, this is the list of problems that you can have by thinking from remote projects. Basically, you don't want to maintain the whole repository, you just want to apply some progressive patches and be able to understand which are the changes that the other project did in there. Tried to solve the problem of big software using packaging. I implemented r2con, which is a simple shell script that is helping to install everything in your home, from programs, libraries, or stuff like that. And there is also the thing that you can install in system-wide. So by default, it's installing everything in your home. But if you specify the -g flag, it will install in system. Well, the reason for this, as I said before, is that at the time there was no other language for choosing this, for solving this kind of problems. But there are good things about C. C is a low-level language. You can do whatever you want. It compiles in all the systems right now. There are support for many editors for it, so you can compile in almost anything. There are so many utilities for analyzing C code and helper tools for finding bugs in this programs written with this language. And when you are having a crash, for example, it's much easier to understand a crash or a backtrace or a compiler error in a C compiler than in a C++ compiler, for example, or any other language out there. So the reason for this is that it's a really old language and it's a really simple and clear language for developing. So it's also easy to debug. So if you have a backtrace, you can quickly understand what is the problem and almost fix everything without having to build again and just click in the pencil icon in GitHub and edit it. But there are some bad sides. The bad side of C is that it requires skilled developers. I mean, you will learn programming C in the university. You will probably need 10 years more for being sure that what you are writing is correct or is more correct than what, I mean, I'm evolving as a programmer, and I think that everybody is evolving in the same way. But I think that for writing correct C, you need at least 10 years of experience. This doesn't mean that it will be for everybody, but there are so many things that can be done better. There are so many things that can happen that you are not realizing about this. And for example, I'm using C without using threads at all. So there are even more bugs that can appear if you are trying to use C in other kind of problems, like having multiple threads working at the same time. There are languages that handle this better, etc. So one of the most important problems of choosing C is that you end up spending more time fixing bugs than implementing new functionalities, and also investing a lot of time for code reviews. But this is good for the community at the end. The code review is really important. C is a weak language. I mean, it's not imposing like a huge. I mean, there are some compilation flags that can help you to identify some common bugs, but this is not working in all the situations. There is no way to identify many bugs in compile time. And there are problems like, for example, different endian sizes, different endians, buffer sizes, handling different resources. The stack size that can be is different for each system, and you can identify the size of it, so you cannot rely on being able to be sure that the stack is not getting overflowed or stuff like that. So it requires multiple reviews, defining on good code practices, using scan coverage and CLang analyzer a lot, and well, fuzzing and testing. The coding style, as I said, is important. I'm mixing the code styles inspired by GNOME and Perl. The reason for GNOME is because I get used. I was coding in JustStreamer and I was trying to follow the rules. So I think that it's good to get used to different coding styles. And for example, I choose to indent with tabs instead of spaces because I think that pressing single key is easier and the file size at the end is smaller. And you can configure at different sizes if you want to see the tab is in a different size. You can do this with spaces. You can also use a regular expression for indenting the code. You don't really need to use spaces, which can be problematic. But I use spaces in other programming languages. But I think that for C is nice. Another reason for using tabs is that many people complain that you are indenting a lot. And I think that this is a good sign that when you are indenting a lot, it means that you should be refactoring this function. Because it means that you are putting too much stuff inside or too much conditional or loops inside the single function, and you should be refactoring this to make it easier to understand and read. We're using the regression-driven development. This means that we are writing the test as soon as we found a bug or a regression. This is not true at all because right now we have no test to be sure that there are no regressions on this. So we are trying to write new tests as soon as new functionalities are done, so we can be sure the functionality is not changing. And the problem of writing tests is that it's impossible to write or uncover all the problems or capabilities or functionality code flows inside the problem. So you will never be able to test everything. We are able to test some libraries, we are able to fetch some stuff, we are able to do whatever we want with the code that is there. But covering everything and having a perfect design from the beginning is impossible. Every time that you make a change that makes sense, it will break some tests, so it requires some time for updating this test or being thinking a little bit about, okay, my change is breaking something, or is the test that is wrong? And having integration with Travis is really useful. So, well, I was about to make a quick demo here, but as it's a bit late, I will try to keep it. But if you want to write a test, just clone this repository into this directory and edit any of the files there. It's basically a single shell script that have some variables. One of the variables specifies the name of the test. Another specifies the comments that must run, and then there is another variable which is containing the contents of the output of the comments that have been run. So the test is just specifying a sequence of comments and comparing the output of them. The infrastructure, well, we have test suite for Linux 64 and the same for OS X. This is thanks to Travis and Jenkins. We have automated Windows builds and same for Android, for all architectures. So every commit is compiled for these architectures and platforms. But for iOS and the Android updates are not happening from these servers. So I'm doing these updates from an offline machine that I have at home. I just plug it for updating, building, and then I push a new release. Well, making a new release takes some time. So when I have a new release, I have usually to spend some hours taking the release notes, checking all the commits, making all the tables, updating the title in the IRC channel, etc. So I'm always forgetting one of the steps, so it takes like 1 to 2 days to end up like having a complete release, and then make the tweets and so on. So it takes some time. So hopefully, following the rules that I've been saying before, I can speed up these times, and we are writing a shell script that is automating most of this. The Endianness is one of the most big problems in C, because when you are writing in C, you are usually testing what is going on in your machine, and big Endian machines are not really available right now, unless you have like a G5 PowerPC machine or other machines that are powerful enough to be able to run a full Unix system and build rather in a short time. Otherwise, it's hard to do that. Actually, we are using QEMU PowerPC on a server for building this. And well, some months ago, Damo22, which is a guy that appeared in the IRC, was suggesting that he can be fixing all these problems, and he's actually fixing most of them. The thing is that we are using an Endian safe development. This means that when you are taking a number or writing a number, you should be specifying the Endianness that this number should be stored appropriately. It's also problematic because when you are reading, for example, a file format, you cannot just map the structure in local structure with a pointer. So you have to read all the fields of this structure, knowing the offset of these fields. And this cannot be done just with a single format string. Every compiler can change the offset of the structures. They can add some padding between the fields if it's not packed, etc. And so it requires some more work than it seems at first sight. But it's a nice thing to have. It's also making the execution a bit slower, not like maybe 1%, something like that. It's not really a problem. But I think that correctness is more important. Number leaks are also another problem, but this is not really dramatic, at least for the kind of use that we're having right now. You can use buggering to generate a profile and then use Qt GUI to analyze the memory size. There are other tools like dtrace for OS X, which is also helpful from instruments to get this kind of information. So it's tracing all the heap usage, and you can define which kind of objects are allocating many times. So if you have like any small location, you will start filling the heap and to slow down execution. So there are also some other problems. So sometimes you have to choose between leaking or double freeing. Usually it's better to leak because double freeing can be a security problem. It's also an execution problem because it will end up crashing the application. So we're trying to get better on this, but it's not really a huge priority as long as it's not leaking in most common uses. Right now, I have a radar instance running in a server, and it's closed radar.org. This server is basically trying to stress the instance in order to identify all the problems that can happen for long running sessions in Radar. And this way you can identify if somebody is crashing it, why it's crashing it, and I don't really care if somebody has, because it's running a shared environment. It's a machine that it's only having this version of Radar, and there is nothing else in there, etc. So it's just for having more feedback and so on. Still have many other problems. This is some of them, but you can find many null references, buffer overflows, heap overflows, underflows, format string problems, use after free, pointer alignment issues, double freeze, corrupted pointers, memory leaks, etc. All these kind of issues can be fixed with review, with tools or helpers that can be giving you some feedback before committing, etc. So this requires a lot of code review and some migration to the new contributors. So there are other languages that we can choose right now, but the rules that I want to follow to decide which other language can I use for a specific project, at least for radar2, is that the compiler should have a big runtime library, or at least have no runtime library, so it will be possible to compile this project for kernel side or for cross-compiling to other system that is embedded, and it's not having problems of space and so on. There is no garbage collector. Yeah, having garbage collector can be useful and nice, but there are other solutions that can be better. It must be a low-level language, so you have to be able to touch what you want. I mean, if you want to specify or do some inline assembly, you have to be able to do it. And it should be easy to talk about. I mean, it should be easy for the people that join the project to get in touch with the language. You can Haskell, for example, because it's something that only few people know about it, and it's complex, and you require a lot of background for starting on this, because most of people start learning imperative languages, and this requires some mind shifting that will make the project worse, because there is less people experienced on this. So there are some languages like Rust, which is probably the most interesting option right now, but there are also some bad points on this. I mean, Rust is able to not have any, it doesn't have a big runtime library. There is no garbage collector because the compiler is able to identify the lifetime of all the structure and objects you are locating. It's a low-level language, and it's an imperative language with some functional capabilities. So if you are coming from C or any other language like this, you can get used pretty quickly to the project. This is obvious after seeing how these last 2 years in the summer of code, some students that only knew C and C++ and so on get really used to Rust in 2 weeks or 1 month coding on it. So the bad point is that it's a young language, but it's stable. But there are evolutions and new syntaxes and better ways of doing things. So it requires some time still from the developer side, and same for the project side. It's hard to find experienced programmers because it's a young project, and it requires a little mischief. There are other languages that can be fitting in this field. That can be Swift, Bala, NIM, or OOC. Bala, NIM, and OOC are languages that are high-level ones, but are compiling to C. So at the end, you have the same power of C, but you have a better syntax. So finally, the source code is shorter, and it's easier to read, and it's easier to maintain, and it's solving some of the problems like parallelism and so on. So as long as radar2 is modular, you can start replacing part of it in other languages. Actually, you can just write plugins in other languages, but it will be possible to write any other of the models like REO library or rutil library in any other language, and you can just replace the shared library and it will work. For performance, about big files, yeah, these are the issues that can be affecting the big files. If there are so many flags, if there are so many functions in there, if there is a lot of meta information loaded, comments, stuff like that, it will be slower, obviously, because it should be checking when you are disassembling in more data structures, checking if there is if you are inside a specific function and so on. This can be fixed in many ways, but there is no perfect way for doing this. You end up having to mix different data structures like linked lists, hash tables, binary trees, and so on, in order to expose the information in a generic way to be used for example, checking which is the name of the flag that is in this offset, and the same in the other direction. So if you have the name, you want to show the offset. So at the end, you want to have a O1 time computation for grabbing the two directions. So this way you can optimize this kind of. The input of this is complex. I mean, there are from different layers, there are sections, there are maps, there are different layers that will be checking every time that you read or write to the queue. So this is slowing down a little bit all the process. And also, when you are, for example, disassembling a function, you are reading and writing doing more than one read, because you are reading every basic block instead of reading the whole block and then just moving the pointer. Also, it would be possible to just have a single map and just read it directly from there and just have some wrappers for avoiding some overflows. This is implemented in r2con library. Well, it's just an API inside r2con. And this can also be another way for optimizing this problem. There are also some stuff that is happening more than once. For example, in Arvin, if you add a printf in get symbols function of any plugin, you will find that it's called more than once. And for example, for remote debuggers, you will find that the debugger is reading the registers many times, or reading the memory not really required because nothing changed in there. So this can be fixed by catching some information and also reducing the number of reads, and it's not required. But this is something that requires some time. About SDB, there are some good and bad sides. The good side is that it's an easy-to-use hash table. You don't have to care a lot about memory leaks, because the API is to use, and it's quite clear that what you are getting is something that you must be free, because you get the ownership. And if it's const, it means that you cannot modify it or free it. So it's not yours, so you don't have to free it. Another thing of SDB is that you can inspect this database from the user. It's everything based in text, so you don't have binary blobs that are hard to read from the terminal. But there are also some bad sides. The hash table is not always the best way to represent something. Strings are not always the best way or the most optimal way to represent anything. It's used for storing data in projects, but it's not used in all the data structures. So there is more work to do in order to devise all the data to code. The analysis is also another big problem, because we are using a single definition of analysis loop. This single definition is using some colors on every plugin, and this way it's using the information from each architecture in order to loop in the main analysis loop. Other projects are using or rewriting, a separate analysis loop for each of the architectures. But this is maybe better in order that if you make change, you are not gonna break things. But it's less generic. You have to maintain more code. You have to repeat more of the same. And well, the idea is that we will end up mixing analysis and assembly libraries in order to not disassemble twice every time that you are getting an instruction, because right now you are analyzing first to get the information from the code and then disassembling. And this is not something that you should be doing all the time, because many times you can just get it once or at least catch this information. The recursive analysis is weak. There are some problems with it and some definitions. Like sometimes you want to have a basic block that is in fact a function, because the compiler is reusing a specific basic block for more than one function. And this requires some more writing tests, reporting, and so on. So if you find any of these problems, just report it. And there is also rest problem, because analysis is huge. I mean, the amount of information you can store, it can fill many gigabytes for just 1 megabyte program, for example. And sometimes it's faster to analyze twice than storing the information and getting it from there. So you will get also good feedback, because it will be performing good, but you will have not the memory problem. There is also some problems with parallelism and threading. I decided to make a simple design, so not using threads, not using any kind of complex thing that can make the development more problematic. And I'm trying to impose that using coroutines and asynchronous and parallel development is better. So the idea is that every of the long execution functions, like for example, you're searching a specific keyword in a whole hard disk, it should be possible to stop this and continue later. I mean, every function that has a long run execution time, it will be able to stop and recover the previous state and continue from it. This way, the user can Control C and continue later the analysis or search, etc. This is not done, but it's work in progress. There is also another important or useful thing is that doing queues. So if you have being able to do analysis in background and you want to run more commands in background, you should be able to create a queue of commands or a queue of functions that you want to call and push them one after the other. So right now, for example, you can run the web server, run any command, just appending it with an ampersand in a separate thread. But this is not checking for boot access at all. So if you are trashing the web server, you will end up crashing the server. About debuggers, as long as it's monotask, you cannot have a shell when the process is running. So this is pretty common in many debuggers and so on, but it's a problem if you are writing a user interface because you always want to have some kind of feedback, unless, for example, like if you are trying to interact with the process. Radare2 should be able to tell you that the process is running, so you cannot do anything like that, or give you the previous information that it was catching. This requires some definition and designing, so it will take some more time to do it, but I think that it's interesting to be able to have the prompt all the time in a synchronous way. So you can continue until some specific address and type other comments that can be queued and executed when when the debugger gives you the control again on the process. It will be also interesting to port DMH, the if analysis function that Axel and Javi implemented in Radare2 to other platforms, maybe OS 6, maybe iOS, maybe Android, maybe Windows. So, and there is also some interesting work that is going on for supporting the debugger for Windows, for kernel. Well, about buildings, I explained a little bit before. As long as the APIs are one-to-one with the CPI, you end up having non-idiomatic buildings, so that's not really natural when you are typing any language. And there are some problems and some restrictions in the development of C. So, for example, I'm not using unions at all because there are other languages that doesn't support unions, and this is a problem because at the end you can optimize some memory and reuse some structures in this way. But as long as it's not supported in many languages, so for example, Bala doesn't support this, I try not to use it in public APIs. So if it's an internal API, I can use that. But if it's something that should be exposed to the user, it should not be using unions. It's using a list a lot, which is nice, but it's a non-optimal data structure. I mean, you cannot map everything with a list and get for one times for every query. So there are some implicit ownership rules. As I said before, if something is returning const, you don't have to free it because it's constant, you cannot modify it. And if not, it should be returning something in there. So defining these kind of rules in the syntax is important because at the end you end up having easy to bind language APIs, and it's also useful because at the end you will have less bugs and more consistent source code. And the namings are also important. R2 aim to fix the problem of building. So right now, if you have a problem with load speed, you can. Many people think that the FFI bindings are fast and should be faster than R2, but this is not true at all. I've been doing some tests, and in fact, using R2 is faster than using the diff APIs. And the reason is that if you are doing, for example, a linked list of 100 objects from C to Python, for example, FFI will be parsing all this binary data, converting and creating new Python objects, and bringing the original data structure and exposing the new data structure to the. This is a problem because this is really slow. I mean, at the end, you end up creating a lot of objects and parsing and so on, and this is slow. So the thing is that JSON is a format which is supported in all the languages right now. All the parsers are trying to be as fast as possible. There are so many parsers for many languages, so you can find even faster implementations. And if you are in all languages in the standard library, they support this. So it's easy to port and integrate with other languages. So the thing is that if you deserialize the JSON object into a native language, so for example, you parse JSON in Python or in Node.js, it will be faster, like from 2 to 10 times faster than using it. Well, if you need speed, there are so many different ways to use R2pipe. You can start using it by spawning a new instance of radar. You can use file descriptors to pipe against the instance of radar. You can use native APIs like DLOpen, so it will be just calling the C APIs directly from the language, so just having a small FFI payload. And there are also some slow but useful communication channels like HTTP, TCP, RAP, etc. So depending on the needs that you have, you can even launch more than one instance of radar, and using R2pipe is pretty easy to run commands in a synchronous way on all the instances and collect the information in a single thread that is using multiple instances. Another complaint, which is probably the main complaint of all the new users, is that there is no user interface. Writing a user interface is boring, so that's something that it's a big problem, mainly because when there is a project that's evolving really fast and you want to write a user interface on top of that, you have to stop writing the code. And I don't want to stop writing the code. I think that it's the most important part of the project. It's something that it's easy to hack, it's easy to use, and many people will get benefit if the core is correct, is faster, and evolving and more modular. And the thing is that the core should be able and free in order to be able to integrate with other tools. So I see the user interface as something that can come up in a separate project. In fact, there are several user interfaces. And obviously, the shell is the most powerful and expressive way. I mean, Unix, for example, when they implemented the X11 protocol, they broke many of the Unix concepts that was behind the system. Because there are, so for example, many things that you can do in the shell that you cannot do in a graphical interface. You cannot use pipes, you cannot use radare2, you cannot do things like that. Plan 9 have some good concepts on this, but it's not really evolving completely. So it's not a fully usable or handy. I mean, you cannot compare a Plan 9 user interface with a Windows 10 user interface or OS X or anything like that. So the shell will be always be in quite hard and better than any user interface. And also, if you want to use this remotely, you cannot use a user interface remotely as easy as you can use a command line interface. So rather in a server, in a computer or anything like that, but you will not be running a user interface in this kind of environment. So the first solution came April fall of last year. I just wrote a Node.js program, which is Blazor. This program is using the Node.js library, which implements some courses like APIs for doing Windows, writing stuff inside, and drawing and so on. I can make a quick demo now. Okay, so this is Blazor. This is a Node.js program that is using r2pipe for launching different commands in Radar and getting the output. You can use the mouse wheel for scrolling into this assembly. You can do the same for the extant. You can get the help like this. You can change the position of the window in many places. You can run commands in the windows. You can do, for example, like things like that. And you can manage the windows in using the keys. So you don't have to use the mouse at all. I think that this is nice user interface when you're interacting with remote instances of Radar. So you can just talk with Radar, for example, cloud.radar.org with this. Just specify the URL as a parameter. And this way you can just use any remote system with a nice user interface, and it's catching the output. So when you are scrolling, it's not slowing down the execution. There is also the web user interface. Let's make a quick demo. This is the material-like web user interface. I don't know if you can quite see it correctly, but it looks like an Android. So you get all the information here. You have a side panel with different options for choosing different categories. So, for example, you can get functions. Then you can analyze the symbols or analyze all the codes. So you get some more functions in there. You can check the disassembly. You can check the extant. You can also check all the flags or change the flag space for grabbing only some flags from this space. You can also do some scripting. You can send this here. This is a Hello World program in JavaScript. This is using r2.js, which is a simple JavaScript file which is abstracting and can be used from Node.js, any web page or things like that. You can also to complete from here. So if you want to shift to the entry point, you can just click here. You can also have to split and have the example in one side and the disassembly on one. You can get a shell in there. So it's a handy web user interface. I mean, it's not perfect. It's there is a lot of work to do, and if you want to enhance it or do whatever you want here, you're welcome. Because I think that writing HTML is easier than doing anything in any other language, but it gives you like pretty good results in very few time, and it's something that almost everybody can do. You can just run a command, parse the JSON information, and write some tags in HTML, and you will get this. Okay, so those are there are different web user interfaces and can be installed using r2pm. But people want native APIs, native user interfaces. The thing is that writing native user interfaces is not optimal. I mean, if you are trying to use a generic framework that is working in all the platforms, it will look alien in all of them. So some of the main projects, like for example GTK and Qt, are trying to resemble the feeling of the native system. So they are trying to emulate all the widgets look in Windows or OS 6, but they never really get to be perfect in that. There is WX widgets, WX Windows library, which is quite nice. But I mean, there are so many options in there, but I never find any perfect one. For example, I like GTK a lot, but I think that Qt is easier for developing. But you end up having to use C++ and so on. Well, there is Vulkan, which is a user interface written by Hugo Teso. It's a Python GTK user interface. And there is also Radar. Radar is a PTE web user application that is spawning a GTK window, and you have a VT instance like a terminal from GNOME, and you have different menus. These menus are just sending comments to the terminal, and you get the feedback from there. So at the end, it's just a terminal with some menus and scripts that you can just tap or click or key bindings for launching them. So at the end, what you want from a native user interface is that you want to have more feedback, faster responsiveness. And at the end, if you're developing these kind of things, you end up bored because you are jumping up and down all the time from core to user interface, and it's really tiring. So this is how Radar looks. As I said, it's a PTE terminal, and you have like different categories for options. And if you click on any of these, you get, for example, disassembly, and you can disassemble function or disassemble block, etc. And then you have some menus on top that can be used for launching this. This is already published in GitHub. In fact, it's a port to radar2 of the Radar, which was the implementation for radar1. But nobody I'm not really maintaining it, and it works, but nobody is using it at all. So if you want to play with it, it's a quite small user interface for it. There is also Raggy. Few people here know or have been used or used this user interface. I wrote this like 6 years ago. It's a native graphical user interface of Radar, written in Bala and using GTK ON, which is user interface description language that I designed, which is something like JSON, but it's shorter. So you don't have to specify codes everywhere and stuff like that. And this thing compiles to XML. This XML compiles with GTK XML, and this generates native C code at the end. So you are using a very easy syntax language for defining anything. And I was defining different models for each of the widgets. Well, it's a full user interface. I mean, you can debug, you can modify binaries, you can get a graph, you can have the extend, the disassembly, and so on. But the point is that I was developing this for 2 years, and as long as all the time that I was showing this to private congresses, nobody cared at all. So I totally lost the interest in keeping developing a user interface for it. But it exists, and maybe sooner or later we'll end up releasing the code if anybody wants to contribute to this. But I'm actually porting it to GTK3, and this is breaking so many things. So this is the little surprise that Hugo Teso have been doing behind the scenes. He has been implementing for 1.5 years a new user interface for Radar written in Qt. And he sent me this video that I will show you at 4x speed. Here you have the list of projects. You can open the specify different architecture or just use the automatic one. You can change the offset, load offset, analyze the program at loading, define the level of analysis that you want to perform at loading the file. You can change the syntax here, some basic disassembly options before loading the project. And then you have some basic information and overview of the binary. It says that, for example, if there is something wrong, it shows it in red. Like, for example, this binary hasn't been compiled with SOR. It shows the size of each of the amount of functions, imports, etc. Here you have the disassembly, you have a graph of this function in the right side. Here you have information about the function itself, so it comes the number of its refs, cyclomatic complexity, and length, so you can have like a visual view of the information of each of the functions. You here have the information about each of the instructions, so you can click and get the zero expression and offset information. The xrefs can be clicked here, and you get the sticking to the address that is going there. You get this assembly just with no solver. You can click here, you have a side panel for having more than one column of disassembly, which is something that I used to need many times that I'm doing reverse engineering, because at the end, having a single view of disassembly is slowing down your analysis. And then you have a side panel on the left side that you can choose for hiding or showing any of these widgets. There's a context menu that you can use for changing, for example, the syntax or removing some of the information that is displayed in the user interface. You can rename functions, see all the hrefs of these functions, and jump in there. Here is a graph user interface, which is based in HTML. It's the same one that it's in /p. You have a top bar for expressing, changing the address of the new position that you want to go. You have the XDAN view. You can also select a range of bytes, and you will get the representation as you want. So you, for example, just select some bytes, and you get the right filling a specific structure that you want to see, like this. So you're disassembling this part of code or you want to get the Python representation of this Python flow. You can just copy paste this. I mean, all this stuff is something that you can do with a command line. It's just a user interface that it's running some comments behind the scenes and making it fancy for the user. Here you have the sections. You can click and see the size of them. Each of them, you can order all the columns. You have a browser for comments, which is also really nice because at the end, I'm really used to use comments as a way for specifying different interesting parts of the binary and not just labels. You have a list of functions. You can see a preview there. Same for strings, imports, symbols. Then there is also integrated notepad, which is saving a text file inside the project directory. The notepad is also working in radare2. To have a command for spawning a beam instance or any editor that you have configured. And you will get a single file that will be saved inside the project file. So you can have side notes for all the area of the project you are working on. You can just copy paste stuff in there or just have some corrective comments. There is also maybe it's too small. You can also run some comments, something like Atom Editor is having, that you can start a comment with 2 dots and then you have a easy to read like comments. And you also have a side panel that you can use for launching scripts or starting the web server. So you can also change the theme. This is a white theme, but there is also a black one. You can move all the widgets. There is also a calculator. There is also an assembler, disassembler widget, which are basically helper windows that are calling the RAS2 or Radin, etc., or RAPs. This is the SDB browser, which is a browser for taking all the information that is stored inside the SDB database. You can put any of these windows in any of the panels that are inside the user interface, so you can change the position of anything, or just make it floating. There is a console that you can run comments in there, so you have a shell that is always visible to the user. He was trying to make the user interface crash, but it didn't crash. So this is what else wanted to present here. The thing is that this is the official presentation, but it's not going to be the public one because we want to work a little bit more on this. So don't make clicks on this yet. Please. So some of the reasons for writing this is that he had fun writing user interfaces, which I don't. And he was willing me to have a user interface that I can maybe sell or maybe provide some people or users until it's fully disabled. But the good things of this user interface is that it will be linking dynamically to the radar2 libraries. So you can have a user interface that will not be open source, but you can modify, change, update all the libraries, plugins, extensions, anything like that. Well, I didn't really decide how to publish, maintain, and release all these things because in fact, I don't really have access to the source code of this. But he has been doing this privately for his own, and he will give me all the source code soon. So I will be able to start setting up something on top of that, like selling support or anything like that. Questions? Well, something that I want to make clear is that radar2 will always be free and open source. I'm not going to change this model. I don't want to make I don't want to break the community. I don't want to break or make people think that this is going to change the the way that I'm developing or the way that I'm maintaining the project and so on. But many people think that this way it will be easier for companies to start using this, or for people that are starting to use Radar, to be able to use Radar from Windows or any other operating systems that are not really integrated with command line. And I also think that most of the people that are really hacking into the project or doing stuff in there will continue using the command line. In fact, I will keep using the command line, and I don't have any really interest in having like switching to the using a graphical interface, because I'm using a Mac, but I'm using Ether in full screen all the time, so I'm just used to use the command line. But I just think that there is some people or companies that will be interested in having this kind of thing just for formation, having access to easier interface and having some support. Well, if you are thinking about what will be the price or anything like that, or the license or stuff like that, I didn't decide yet. I don't want to make this thing inaccessible to the people. I mean, it's like this Congress, how I did it. So I'm not gonna make like a huge price for free. In fact, I'm thinking in organizing different competitions and giving up some license for free and stuff like that. So my idea is to have fun out of it and be able to have some rewards of all the work that I've been doing, and reinvest in part of this money for the community, the project, and we're looking for more contributions if they are interested in working on the project or the user interface, etc. So, if you have any questions apart from this. Okay, so I think it's clear.